chairperson, organizer, fellow presenter, and esteemed audience. I am Salam Ali, a doctoral student at Hamad bin Khalifa University under the College of Science and Engineering in Qatar. So based on my study, I would like to present to you on the temporal trends in greywater and treated effluent quality. This study examined the water quality of greywater and tertiary treated sewage effluent over time, highlighting trends, implications for sustainability, and providing practical recommendations for use. It focused on water-scarce regions such as Qatar and other GCC regions, and also aligning with the SDGs, and also based on a Qatar water strategy. So here I'll be talking about the background, the study objective, methodology, key findings, policy recommendation, and suggested future work to support the safe use of water. So to the background of the study, as you can see from the slide here, this slide highlights why water reuse matters in Qatar and the GCC country. So you can see from the report highlighted by Alishan and Zubari, we have a different water use by each sectors. The major problem is not the volume of the water generated, but the use of the water per capita. So according to some of the studies, it reached over 500 liters per capita per day. So, and also Qatar is a country without fresh surface fresh water. So they depend mainly on conventional water sources such as desalination. So on the other part of it, you have the fraction at which water is used by each section. So all the water used except the one used in the toilet contribute to greywater. When you're including toilet water or the water coming from other sectors like hospital, industrial waste, make the total wastewater, which after being treated, we call it treated sewage effluent. So part of it is used in the farms, lagoons, and also artificial ground recharge. So from there, so also these are part of main concern for the study, which contributed motivation. Freshwater scarcity driving community to seek alternative water sources. Grey water from showers, sinks, and laundry, along with treated sewage effluent, can be used for landscaping, cooling, and other purposes, reducing reliance on expensive desalinated water. However, their quality varies. For example, grey water can be highly contaminated on some days and clean on some days, on others, depending on usage. YTSE, on the other hand, its quality depends on the treatment method. Previous research also provided only snapshot of water quality, but planners need to understand why this quality fluctuates over time. This led to longitudinal study where weekly testing aimed to monitor changes in water properties and helping ensure that reuse remains safe and effective over the long term. So these are the study objectives. It's aimed to track how water quality changes over time, compare the consistency of grey water and treated sewage effluents, and understand how storage conditions affect the quality. So this part of the significance of the study. So for example, the study supports SDGs by identifying water quality trends that enable safe reuse, improving efficiency and reducing reliance on desalination. It aligns with Qatar's goal of 100% wastewater reuse by 2030, and emphasizing the need for data-driven policies, safe reuse standards, and source management, especially for large-scale applications like agriculture and urban irrigation. As you can see from the picture here, there's a building I put here. This is one of the newly adopted Qatar National Code they put inside the building strategy. The reason why they are doing this is that they want to have the on-site grey water treatment, whereby the water is used for domestic purposes, except for the one using the kitchen or toilet waste. We'll go back to a package underground package water treatment system where it's being reflushed, treated, dechlorinated, and also being sent back to the system for toilet flushing. So these are the study design. So let's discuss about how the study was carried out. We collected samples once in a week over a period of 2 months. We examined two main water sources, which is the grey water itself, which contains a mix of domestic water use, excluding toilet sewage, and also TSC, the final effluent from a sewage treatment plant used for reuse option. Importantly, they sampled each at 2 points. The first point is the one that's coming into the system. I mean, the one coming from the freshwater used directly. For example, for the TSC, we have a network for distribution that comes from the Doha North Distribution Center. And also another one is from our female dormitory, where they are using the water. The water that's coming from there is not going to the distribution plant, go back to a separate water treatment system where the water is treated and reused within the same step. So here are the result and discussion. First one, the temperature and the pH and turbidity. So here we use this one because it was measured on site for the physical water quality parameters. We have other two that I mentioned, but because of the slide time and limitation, we couldn't include all of the results. For the temperature, different temperature fluctuates across all these three systems. For example, in the summer period, we noticed that there's a high rise in temperature from the water coming from TSC because of the long distribution line and also high temperature condition in Qatar that can reach up to 50 degrees in the summer. And also for the tap water, this also impacts the tap water because most of the water are stored in tanks before being used in buildings. This same thing also affect gray water coming from the inlets and the storage tank. For the pH, you can see the pH also varies significantly. TSC is having very high pH because of the tertiary level of treatment, which also include the remineralization of the water to ensure it meets effluent quality standards. From a turbidity aspect, you can see from the gray water inlet and gray water storage, there's a lot of difference. This impact that the storage impacts the gray water quality by increasing turbidity. Since most of the water is coming from laundry, bathroom, which contain different activities. So storing the water with time increases the turbidity, which also affect the water quality. So here's organic loads. So for the organic loads, we talk about the chemical oxygen demand, the COD, total organic carbon, which is the TOC, and also biological organic demand, which is biochemical oxygen demand, which is the aspect of the chemical oxygen demand that is biodegradable. So here, normally what we usually use to impact treatment is we look at the biodegradability of the water. For example, if you have up to 40% of your COD, that's BOD, then it indicates that this type of the water can undergo biological level of treatment. So nevertheless, from the gray water, it ranges from 0.4 to 0.6, which occupy 40% of the COD. So this indicates moderate biodegradability. YTSC had a very low ratio because it has already been treated in the wastewater treatment plants. Also for the nutrient contents, we analyze for specifically total nitrogen, ammonium nitrogen, and also nitrates. So from here, in addition to that, we also have the soil phosphorus in terms of the phosphates. So here, total nitrogen is very high in terms of the TSE compared to gray water in the first month. But with time, because of the storage impact, also affect the quality. For the gray water, in the next month that the sample was sampled for the last 4 weeks, the water has increased drastically. So indicating that the storage also impacts how the water moves in terms of the nutrient content. And also the ammonium nitrogen contributes more than 50% of the total nitrogen source from the gray water. But in TSC, because already treated, we don't have much ammonia, less than 0.5 most of the times. But for the nitrate, there's a lot of nitrate because it has to meet landscape irrigation standard. So the last one is salinity and chlorine level. For the salinity, we use a conductivity which give the total estimation of the ionic content of the water samples. As you can see from here, the gray water and tap water, they have moderate level. But if you look at TSC, this is very high because this also impact of the desalination and also the impact of treatment, especially the chlorination, the addition of some ions like magnesiums, addition of cations like magnesium to reduce sodicity of the water in the soil. But nevertheless, our study plans to assess the salinity effect with time. So here is the research challenges and the treatment opportunity we find from our study. For example, from the gray water, the quality is very variable, and also it contains a lot of particulates. There's other issue, there's sometimes microbial growth because of the way water is being used. And also during treatment, it causes a clogging issue. Sorry. And also from the aspect of the TSC challenges, we have the high salt, potential for soil salinization, toxicity, and regret potential. Some of the solution for the gray water is to develop salt-specific treatment, where you have a package system that separates the solid before going for the biological treatment. This may improve the system long-term operation. From there also, we have a storage consideration, like we said, quality change with time when they are being stored in storage tanks. There's also slight salt concentration, which may be due to the evapor concentration. And also from there, some of the solutions we suggested is to minimize retention time. Where the water is stored, it has to be used on time. and also provide aeration or circulation for a long-term storage. So the last one is to adopt nature-based solution, which is also part of our work in our lab. So we want to adopt this nature-based solution to either treat the greywater further to meet discharge standard or polishing the TSC to reduce the salinity effect. So this is the last part of the slide presentation. It's all about the recommendation. For example, here we are talking about the policy and practice recommendation to support the safe and sustainable use of water. First, it's crucial to develop source-specific treatment standard. Greywater should be treated on-site at community or building scale, while treated sewage effluent remain post-treatment, require post-treatment, polishing to reduce salinity and improve quality for the use. And lastly, capacity building is also essential. For example, training operators and gardeners in the management of reused water ensure system sustainability. Equally important is raising public awareness to encourage acceptance of treated wastewater for safe reuse. Finally, policy integration is vital, updating the building code, so include dual plumbing system for greywater separately from the rest of the wastewater. And also, this can help us to improve, we can improve this strategy by helping the Qatar meet its national vision by 2030 goals and advance SDG to ensure clean water and sanitation for all. So lastly, this is a part of our future work that we plan to work on. So here we try to extend the collection of the wastewater with time to capture the seasonal influence on the water source. And also from there, we try to adapt some media selection and try to do some treatment performance to see the intrinsic treatment performance of some of the media. From there too, we also try to move on to a more industrialized wastewater from a GTL, gas to liquid factory, whereby we want to use microbes to degrade the water and to ensure it's sustainable for the use. So thank you.